In this video, we will look at the numerical summaries of data. So we'll still work with descriptive statistics, but in this lesson, we will be looking at some of the numerical measures. Specifically, we'll look at measures of location, measures of variation, and we'll also look at measures of relative distribution, and we'll end with looking at relationship between two variables or two data series. So before we start digging into numerical measures, some basic preliminary concepts. In statistics, we are often interested in determining or studying or asking questions of population variables. So we're interested in studying the population, but very often we do not have access to the entire population. It's costly, it's impractical, and in most cases it's not even needed. So instead of examining the entire population, we often draw a sample from the population. And the sample ideally should be random, should be representative. We'll talk in detail later on more about what these terms mean. But sample is a snapshot of the population, and this helps us study some phenomenon or some properties of the population. So we'll also draw a distinction between a term called parameters and a term called statistic. So parameters are measures of interest of the entire population. For example, population mean, population variance, population standard deviation, and we'll discuss what these measures are. But because we do not have access to the entire population, we will not know what these actual measures are. So from the sample, we can proxy population mean by looking at the sample mean. For example, we can get an idea of the population standard deviation by looking at the sample standard deviation, and proportion, which is the number of yes responses over total number of responses. In the case of a yes and no kind of a question, population proportion by looking at sample proportion. So these sample measures are called statistics. So sample statistics are used to draw inferences upon or about the population parameters. So as a rule of thumb, we will denote the population parameters with Greek letters, and we'll denote the sample statistics with numerical letters. And once we actually find a value for the sample statistic, we'll call it the sample estimate. So estimate for the mean, estimate for standard deviation, but the formula is called sample statistic. So the first sort of measures which tell us how our data looks like, where our data sits on a scale, where do the values lie, for example, is the mean. To calculate the mean of any series, we add up all our observations and we divide it by the number of observations. So the summation sign or sigma is the addition sign. So xi, where I is any observation, ith observation. We have 1 through n, so we add up all the x's divided by n. Now, very often, an average or a simple mean may not tell us a lot of information. Another related concept, and we'll look at some examples, is weighted mean. Weighted mean is basically we're looking at the sample observation or sample data points, but we are weighing them by their occurrences, for example. And then we divide that by not the number of observations, but the sum of all those weights. And we will use this measure quite often later on in our analysis as well. So the first type of mean we'll look at is simple mean, then the weighted mean. In business, a lot of series demonstrate growth or decrease over time. So returns to a stock asset, returns to any saving instrument, for example, when the interests are not predetermined. So sometimes there's growth, sometimes there is decrease. Now, if there's growth, it is from what it was last year. If the following year the asset goes down in value, the decrease is from what it was this year. So if we take a simple average, we might get a distorted view of what the average returns for an asset would be. So in those cases, we look at the geometric mean. In geometric mean, first we find the growth factor. So from base one, let's say an asset grows by 20% in year one, then drops by 15% in year two, then goes up by 5% in year three. So the growth factor is always with reference to one. So for first year, growth factor would be 1.2 because the asset showed a growth of 20%. In the second year, we said it declined by 15%. So the growth factor would be 1 minus 0.15 or 0.85. And then the third year, from where it was, it grew 5%. So it would be 1.05. So we calculate the growth factor for the entire time period for our data set. We multiply those growth factors and we take the nth root, where n is the number of periods for observation. And that will give us a number with reference to 1. So we might get 1 point, let's say 0.05. So if you get 1.05, then we subtract from 1, we say that the growth was 5%. If the number was lower than 1, we might say that then overall the asset experienced a return in its growth or in its value. The other measure which you all may have heard a lot about is percentiles. So mean is looking at the average value. Median looks at the middle value. So in this case, when we sort our data from low to high, the middle value is the median. In case of our data set being an even number of observations, the average of the middle two values is the median. By nature, median does not depend on the outliers because we're ignoring the extremely high and the extremely low values. All we're looking at is the value or two values in the middle. But median is a specific case of what we call a percentile. So percentile is basically telling us the percentage of data that is below a given observation. So if we say that this particular data point is the 85th percentile in our series, what we're saying is that 85% of observations lie below that. Thus, median is the 50th percentile. So half the values lie below it, and then by default, half the values lie above it. But it's a very general form, and we can look at any percentile, not just the median. In fact, we will look at three different special kind of percentiles. Q1, which is the first quartile, which is 25th percentile. Q2 is the median, and then Q3 is the third quartile. To calculate median, again, it's location based. So we essentially find the location that corresponds to the percentile that we're interested in finding out. And then, so the formula we use to find that location is the percentile that we're interested in, P, divided by 100, if it's not already in decimals. And then we multiply it by n plus 1, where n is our sample size. Now, if this number is an integer, so we can just count to that value, and that value is our pth percentile. What if that number is, let's say, 11.4, a decimal? So what we would do is we would round up and round down. So we would look at our 11th value and then the 12th value. And because our location is 11.4, it is 40% of the way in between 11th and 12th value. So this difference that we get between 12th and 11th value, we'll multiply it by 0.4. So 11.4, that means the 11th value plus that 0.4 of the distance between the 11th and the 12th value will give us our relevant percentile. And again, as we'll see, the software packages will calculate these very easily for us. Then, as we said, median is the 50th percentile, but then we're also interested in the lower quartile, 1/4, so quartile 1, quartile 2, and quartile 3. And then mode is the value that occurs the most. Calculating descriptive statistics of numerical data in JMP is very easy. Again, we have seen this analyzed platform. So let's say we have data on tariff rates. These are percentages. And we have data on imports. Now we can think of these as like in tens of millions of dollars. So 4 means $40 million worth of imports of a particular good. So let's say we're interested in finding out some of the location for tariffs. We go to Analyze, Distribution. We're interested in examining tariff. We move tariff as the Y column. Click OK. And now, unlike the qualitative variables that we have seen before, for a quantitative variable, JMP provides just a lot of information. We get a histogram. Again, we've seen that we can adjust the bins if we want to. But we also now get these summary statistics. We get the quartiles, the percentiles. So JMP calculates a bunch of percentiles by default. 50th percentile is the median. 0 percentile is, of course, the lowest value in the data set. 100 percentile is the highest value in the data set, and which are 69%. And then we have 35% as the lowest value. And then we also get the first quartile, which is 25th percentile, the median being the second quartile, and then the third quartile is the 75th percentile. So all these values are kind of given to us by JMP, and it also provides us the mean. So our average value is 50.89, and our median value is 50. So here our median is very close to what the mean is. We have 19 observations, and we can also customize what statistics we want to see. If we click on Summary Stats, we get a whole lot of options about what specific summary statistic measure we want to display. Again, there are just a lot of measures. Initially, JMP is not overloading us with what we want, but we can get a variety of these measures here. Next, let's see how we can get the weighted average. So we exit out of this menu. We have to kind of redo this analysis for weighted average. Go back to Analyze, Distribution, or we could have kind of continued with that. We move our tariffs to our Y. But now notice there's an option called weight. So here we will move imports to our weights. We click OK. Now this mean that we get is slightly different than the mean that we had gotten before. So if we go back to our analysis, Analyze, Distribution, and now we get an unweighted average. So we see that unweighted mean was 50.89 and weighted mean is 50.7. Now there's not much of a difference, but for a different series, we would have gotten a different value. Essentially what's happening in calculation of mean is that in the numerator, it's 39 times 4, 66 times 6, and so forth, and all of them added, and then divided by the sum of 4, 2, 4, 6, etc. So we can even, in fact, look at what that sum would be in little red triangle menus, or sorry, we can go to the stats menu here and customize summary stats. We can kind of get our sum of the weight, and the sum of the weight is 103. So 103 is adding up all our imports. We can also see what the numerator is. Again, summary stats, customize summary stats, and this time we click on sum. So the sum 55224 that we get is essentially the sum of the product of our tariff with corresponding import values. And this will be quite different than the sum of our numerator or x values here. You can do the same exercise, obtain the sum, and that value is only 967. So if we add this up, it adds up to 967, but if we multiply tariff with imports, and then for each observation add them up, that would have added to 5224, and then that divided by 103 would be the weighted average, but our 967 divided by 19 would be our simple average. Next, let's look at how to calculate geometric mean. So these are annual returns from an asset. First year returned as 15.1%. The next year the value dropped by 23%. The following year increased by 4.2%, and so forth. If we take a simple arithmetic mean here, it will not give us a correct measure of location because the growth was from where the asset was last year. Then the decline the following year was from where the asset was this year, and so forth. So we cannot quite take the arithmetic mean. So we need to kind of create the growth factor first. Now, if we were to just go, we saw that there was an option of geometric mean in summary stats. Had we done that, JMP would have just taken the geometric mean of these values without realizing they're not growth factors. So again, that's not the right way. So we have to first get the growth factor. So I click on formula, and what this column essentially is our annual returns are in percentages. So we'll say 100 plus our annual return. We'll say 100, then plus, I can drag my annual return here, but we need to divide this by 100 because we want to get our answers in decimal. So we can click on division and divide it by 100. So now this simple transformation will give us the growth factor, and I can kind of just call this the growth factor. So this is again telling us the growth in terms of where it was last period. So for an increase of 15%, the growth factor is 1.151. For a decrease of 23%, the growth factor is 0.77. Now we need to get the geometric mean of this growth factor. So we go to analyze, distribution, and we move our growth factor to our Y column, not our annual returns. And instead of simple mean, which again is not quite useful, we will click on customize summary stats, and here we see the option for geometric mean, which should be here is the geometric mean. We click OK. So our annual return, the geometric mean is 1.0179, which means that this asset grew over these 6-year periods by an average growth rate of 1.7%, which is a modest growth. But when we look at these numbers, had we mistakenly taken an average of this, so we go to analyze, distribution, and we return annual column, look at the mean. So 2.276. So this shows that simple average wise, our average growth was 2.76%, but the correct measure for this asset's growth is actually 1 minus 0.0179, so it is only 1.79%. So geometric mean is used whenever there is on an annual basis or quarterly basis or monthly basis the idea of growth or decline from its past realization.